here's the next question, number 41. The power consumption of an industry is 500 kVA at 0.8 power factor lagging. A synchronous motor is added to raise the power factor of the industry to unity. If the power intake of the motor is 100 kilowatts, the power factor of the motor is dash. So since we're dealing with power factor, we have to find out what the power factor of the motor is. We will need both the reactive and the active power of the industry first. So let's write down what we have. We have the power consumption of the industry is 500 kVA. The power factor is 0.8, which means that cos phi is 0.8. Now if cos phi is 0.8, that should tell us that sin phi is 0.6. Okay? They are a team. Now a synchronous motor is added to raise the power factor to unity, and the power intake of the motor is given. So that's P intake 100 kilowatts. So this is part of the motor rating. We need to find out what is the reactive power as well. So that's our next step. Let's start with the active power. So the active power, we'll call that P1, would be 500 times cos phi, which is 0.8, comes to 400 kilowatts. Next we need the reactive power. The reactive power is Q1, and that's 500 into sin phi, 0.6, and this comes around to 300 kVAR. Now in order to raise the power factor to unity, the motor should supply 300 kVAR. So this gives us the motor ratings. Okay, so now we have the motor ratings as 100 kilowatts and 300 kVAR. So this is our P, this is our Q. Now for phi, we need the angle now. The angle can be found by using the formula tan inverse of Q by P. This is a standard formula. Phi is tan inverse of the reactive power divided by the active power. So if we substitute the values, we get tan inverse of 300 by 100. So that's tan inverse of 3. So that comes around to 71.56. Now this is the value of phi. We need the power factor, which means that we need cos of this value. I hope you're following. So this is the value of phi. I'm going to write it here. So we have that phi is equal to 71.56. We need the cos of this value, cos phi, which is 0.316. 0.316 is the final answer. I hope this has helped.